This is Data Log Educational Concept, bringing the ICT knowledge to your desktops. This is session 6 of the introductory course to Spss part 2. In this session, we'll be looking at continuous outcome measure, comparison of mean using a Ttest, and linear regression. In introduction, in this session, we consider the long function measurement. We are still working with our foundry dataset. Given that a long function is age and size dependent, it is easier to divide measure log function by the expected long function. In part 1, we constructed such a variable. Then, to jack our brain, I have this little exercise for you. Using the compute option in your Spss window, you choose transform, construct a new variable with the target variable to be FEV ratio and FVC ratio. For FV ratio, you will define FEV ratio to be FEV measures by FEV predictive, and for FVC ratio, you will define it by FVC measures by FVC predictive. So go to your Spss window. For some of you that have missed that video, I will just take us through the Spss window for a bit now to see how to compute a variable. Let's go to our Spss window. Okay, this is our Spss window. We'll click on transform, compute variable. Actually, I already have my FEV ratio and FVC ratio, so I don't want a duplicate, so I will click on these two columns and delete it. Clear? Okay, now I come to transform, compute. You click on compute variable. Now the first one I want to compute for FEV ratio. Then for our FEV ratio, is going to be measure FEV divided by measure predictive. I press OK. That is for FEV ratio. Then my output window is telling me that that has been executed. Then the next one is I click on transform again, compute variable. The next one is for FVC. Then that will be measure FVC divided by predicted FVC. Press OK. Now let's go to our data editor window. Now you will see it at the last column on the data view. Now you have a new variable called FEV ratio and FVC ratio. That is computing a variable. We now want to examine whether workers exposed to dust have reduced lung function. We want to know if the workers that are exposed to dust have reduced lung function. First, we might examine the graphically. We might examine this graphically with bus plot. So you go to the graph menu, you select a bus plot here. When you select your bus plot, you will see this coming up. Then you put in your variable from the left hand side here to the variable here. Then your category axis will be exposure group. Let us go and do that. Let us go to our window. Here we are. We click on graph, legacy dialog, and scatter plots. We click define, then is in here. What are we using? We are using bus plot, not scatter diagram. We are using bus plots. Okay, graph. Let's click graph, legacy dialogs, and bus plots. We click simple and define. Here we are now. The variable is FEV ratio. Want to see FEV ratio by exposure group. Exposure group. Then we press OK. So here we have our output here. Our is running. It's coming up. It has been executed. Here we have our bus plot below. Examine variable FEV ratio by group. While we are still waiting for our data. Yes, these are this that we have exposure group, one exposed and exposed to dust. This is the bus plot. So this is what we get. It gives us this plot. Now the bus represents the interquartile range, the whisker represents the range, the solid line in the middle represents the media. This suggests that there is little difference between the dust exposed and non-exposed workers. Other analysis options we might use to compare the lump function of exposed and non-exposed workers are: under exploit, you go to exploit in the descriptive sections and the mean under compare mean. Exercise: use exploit and mean option to compare lump function of exposed with non-exposed workers using FVC ratio and FEV ratio. Record the result below. Do the exercise and submit to our email at datalogtutors@gmail.com. Now next, comparison of mean using a Ttest. The Ttest procedure can be used for statistical comparison of the mean FEV ratio of the exposed compared to non-exposed worker. It will also give the confidence interval for the difference of the two means. For the test, go to compare mean, then independent sample Ttest, which means you go to our window, you go to analyze as described in this picture. The screenshot that we have here saying we go to analyze, you click on analyze. When you get to analyze, you go to compare mean, then you go to independent sample Ttest. So what do we want to do? We want to do the Ttest procedure for FEV ratio of the exposed compared to non-exposed worker. It will also give the confidence interval for the difference of the two means. For the test, you go to compare mean, then independent sample Ttest. So let's go to our window. Okay, analyze. We have compare mean, then independent sample Ttest. Our test variable is FEV ratio. Then the grouping variable is exposure. Then we can define group to be group 0 and 1. Press OK. Here we go. Here we have exposure and unexposed. 63 of the total population are unexposed with a mean value of 1.01. 73 are exposed to dust with a mean value of 1.00. So there's no more difference between the unexposed and the exposed to dust by the mean value. And here we have the independent sample test here, and which shows that there are no significant difference also. Note, beside the variable name group, click on define groups to add codes. That is what I did when I get to that place. I click on these define groups, then I assign 0 to 1 to the value. The ability to select group by choice of code simplify things when there are more than two groups in the data set. If you have more than two groups, you already know what you use to label each of the variables, each of the values. That will be the number that will be put in this area. Then we generate this table for us. Now we take the second row of Ttest result. Let me start from the up. The first summarizes the data of the two groups. The second presents two analysis. The first two columns of data, which is the leveling F test of equality of variance. The assumption of a T-test is that the mean for each group have the same variance. Please note, I recommend that you always use the T-test assuming the unequal variance unless there is a very strong belief that the two groups have equal variance. Therefore, we take the second rule of T-test, and that's what we have here. This second rule, which is 0.514. We take the second rule of T-test result, although in this case it makes little difference. The difference is so small. The result can be summarized as there was no evidence of increased FEV ratio for the worker exposed to dust, with a mean difference of 0.0155. You can see that. Here we have a mean difference of 0.0155 here. This is a mean difference of 0.0155. 95% confidence interval with a CI of 0.0031, and the p-value is 0.514. This is, we assume equal variance not assumed, so we use 0.514. Why do we say equal variance not assumed? Say we recommend always using the T-test assuming an unequal variance unless there is a very strong belief that the two groups have equal variance. We can't be too sure that the group have equal variance, so we always assume unequal variance. That is why the p-value that we select is 0.514. Exercise for you. Compare mean FEC ratio for the exposed and non-exposed subjects using a T-test. From the analysis, there appears to be no evidence that exposure to dust affects respiratory function. It may be argued nevertheless that being categorized as exposed or not exposed is a crude assessment for exposure. Dust exposure has been recorded for subjects in the exposed group. We will now carry out some analysis on just the exposed subjects. First, we select this from the data. This was shown in part 1 of the tutorial. If we go through the part 1 tutorial, you would have seen where I told us that we can narrate our data to a particular data. That's when I assign a group to 1. Then you see how the number of cases were slashed out. That is what we want to do here. So we go to our data, we choose select cases, then we click on the if condition, certify as shown below. We had the condition to group to be equivalent to 1. Let us go and do that. When we have done that, then we plot an FEV ratio compared to dust for subjects. Okay. Okay. We click on data, select cases, if condition, then if exposure group equals to 1, continue, then okay. That has been done. Let's go back to our data editor. Here, what do you observe in this case? You see these cases are slash out. Wherever there's a slash out here, it means that there are no exposure for those cases. So all the cases that there are no exposure has been slashed out of the data. Now let us run a plot graph for FEV. Here we have a scatter dot diagram, a simple diagram defined. So exposure by x-axis and FEV ratio by y-axis. Okay. So here we have our FEV ratio and exposure group. Now let's go back. Let's change the data. Let's change the data type SPSS window. So here we have analyze regression, okay, analyze regression, linear regression. Our dependent is FEV measure FEV, then independent is exposed group. We press OK. That is how to run the analysis. Okay, that has been done. So here we have the model summary table, which should reproduce below tell us one how well the line fits that data. The result for R square, rating R square, is 0.045. This is an estimate of the proportion of the variance explained by the model. A line that fits the data perfectly will have an R square equal to 1, whereas a line that does not explain anything in the data will have an R square of 0. A value of R square equals to 0.045 is therefore not all good, as only 4.5% of the variation in the data is being explained by the line. So the conclusion that can be drawn from this is that while there is a slight suggestion of reduced respiratory function with increased dose exposure, the evidence is weak. Model checking. The linear regression model described by the coefficient allows one to estimate a predicted value. The difference between the observer value and the predicted value is called a residual. Where a model fits badly, the regression line will have large residual. If we consider the scatter plot above the FEV ratio compared to respiratory dose, the residual will be large. One of the assumptions of a regression model is that the residual will have a normal distribution. One way to check this graphically is to use normal probability plot. This compares the residual against a normal distribution. Such a plot can be obtained from linear regression in SPSS, as shown in the next slide. So we go to linear regression, then we go to, after we have input the variable, the one that is meant to be dependent, and the one that is meant to be independent. Then we click plot. By this side, here we have plot. You click this plot here. Now, just select the normal probability plot option. Then the plot will be added to the output when it is rerun. If the residual are normally distributed, the piloted points are on the diagonal line. The plot below suggests that the data are approximately normally distributed. If the data were skewed, the points would budge away from the line. So let us go to our SPSS window. Okay, here we have our SPSS window. We go back to our analyze. We click on regression, linear regression, plots. normal probability plot. Continue. Then we press OK. Let's see. Okay, you see the line fitted to the plot. See, expected and observed. Okay, I give us an exercise to run the same thing for FVC. To do that, you do the same way: linear, regression, linear. Then instead of FEV ratio, what I want to see there now is for FVC ratio. I press OK. Then here I have the graph. Okay, so that is for that. Then this is the end of this session C. So do the exercise, try it on your own. I just did the exercise for us right now. Make sure you also do it on your own. It's just for you to change the dependent variable to FVC ratio and dust level. Now we are talking, your independent will be what? Will be dust level using the method above. See you again in session 7. Do all the exercise and send it to our email for assessment. Thank you.